Good morning, everyone. Thank you for joining us this morning as we discuss what we need to know about patents. So we're going to start off with a brief explanation of who we are, discuss our purpose for today and the agenda. Then I'll introduce our guests. I will ask you, I know everyone has already muted their mics, but just a reminder, if you can keep your mics muted unless you're talking or you have a question. And if you do have a question in the middle of a discussion, feel free to put that in the chat window. We'll be looking at that as well. So my name is Kim Mozingo, and I am with the Maryland Defense Technology Commercialization Center. That is a program of the Maryland Department of Commerce funded by the Federal Economic Development Administration. And what we do, also this morning, Griffin St. Louis and Gary Evans are here from DefTech. Gary is the executive director, Griffin is the program manager, and they're both going to be speaking to us this morning. So what we do is look for businesses that are looking for a technology solution, and we connect them with the DoD labs in the state of Maryland. In a nutshell, that's what we do. But you'll learn more as we go through the morning about what we do and how we help businesses commercialize technology. So we have a variety of different kinds of people on this morning. We have people from biotech and cyber healthcare. We have manufacturers on, big data. We have some people from our federal labs, and as well as a bunch of service providers from Maryland and Delaware. So if you'd like to network with someone or there's someone you'd like to connect with, you can use the chat window. If you're not comfortable putting your email in there, you can add your LinkedIn profile and people can get in touch with you that way. So what do we want to do? So today we're going to talk about patents. We're going to talk about how to read a patent, how to consider a patent from the standpoint of manufacturing. And we're going to talk about developing a commercialization plan. So if you are licensing technology from a federal lab, you're going to need to present a commercialization plan to this. And all of this flows together. We've covered all kinds of topics so far on product development, funding product development, and all of these center around the work that we do with DefTech, which is helping companies take technologies to market. So our goal for today then is to help companies acquire the knowledge that they need to reduce risk in licensing intellectual property. Once you have an idea of how to read the patent, how to understand what you're looking at and what you're looking for while you're reading a patent, we'll switch into talking about the manufacturing perspective, what you need to consider from a manufacturing point of view. After you decide that you're going to license the technology, as I mentioned before, the lab that you're licensing from is going to want to know that you're prepared to take that technology to market, and will expect you to demonstrate that with a strong commercialization plan. So in our discussion today, we're going to look at a technology that's available to license from the Army Research Lab. It's a solid state switch power emulator. And I did put a link to that patent in the chat window. So if you want to follow along, you're more than welcome to do that. DefTech connects businesses to the resources that are available in the DoD labs in Maryland. And much of our work is focused on helping companies and technology transfer professionals engage in mutually beneficial relationships, ones that help the companies grow their business and helps the DoD to meet their mission-driven needs. There's nothing that we do that is going to necessarily exclude someone from working with us or working with the lab. If we find a company has needs, then we work with our network of service providers and other experts and put them in touch with the people that they need to get in touch with. Recently, Taking Technologies to Market, that's the name of our meetup, hosted an event about patent license agreements and cooperative research and development agreements in our Collaborating with DoD session, which you can find, if you missed that, you can find that on our Taking Technologies to Market YouTube channel. From a business's perspective, the first step is having a strategy and a goal for reading and understanding the patent. And once you've decided, you've taken a look at that patent and you've decided that that intellectual property or that IP seems to offer a solution for your company, you'll next want to consider it from a manufacturing perspective. So joining us today is one of our partners, Cyrus, who is the president and founder of RPM Tech, which stands for Rapid Prototyping and Manufacturing Technologies. Cyrus, I'm sorry, I meant to practice saying your last name, which I know is horrible, but thank you for being here. And can you tell us how to say your last name?
Certainly. Good morning. It's Cyrus Etemad Mogadam. People get a little panicked when they read it because it looks so long.
It looks long and it has a dash. Thank you for that. Um,
Not a problem.
So before we get to a discussion of considering the IP from a manufacturing perspective, there
Mhm.
are a few steps that you recommend companies take prior to even meeting with someone like you that can help them, actualize the product. Can you talk about what your expectations are and what homework companies should have done before they contact you about a prototype?
Certainly. And really, when it comes down to it, it's not an issue with contacting us as much as starting to spend funds on having design work and designing a product that's going to be manufactured. Uh, because you want to be ready before you get started. That's what it comes down to, really. And it's true for any business. In this case, it's specific to the patents because you are taking a concept, an idea that was developed, in this case, by the labs in Maryland, and you're trying to take it into a product. And you may have some great idea. You may even think that you know everything about the market, and you may be ready, but you probably don't want to spend a lot of funds on developing the prototype further or the technology until you've done a few things. The first thing is really it's the whole sales and marketing aspect of it. Do you understand your market? Do you know your competition? Do you know what your customers want? You may have an idea of what you think they want, but do you understand these items? And while we don't push away any customers who comes without these pieces of information understood, we try to direct them or to identify areas that maybe there's a gap and it requires potentially some external support. Our expertise, specifically our PM tech, is not in marketing and sales. Actually, we're not very good at that. Our specialty really is taking technology and taking it through all of the steps that are required to get to production. So, my recommendation is always you should look at partners if you're not an expert in that area. And again, each customer that comes to us has a different set of skills. In some cases, they have everything that they need. That's a recurring theme that you already heard Griffin talk about, and I'm sure Gary will be discussing this as well.
Yes. Thank you for that. You talk about them understanding their market and having a good understanding of that, and that's just a smart business decision. You don't want to jump into licensing something that you're not going to be able to actually sell for a profit, which is the whole point of business. Let us know when you're ready to share slides. Okay.
Sure. Why don't we go ahead and start with the first slide? So basically, as you mentioned a little bit earlier, we are a product development company. So our expertise is taking a concept, requirements, a prototype, and going through all the phases necessary to get the product all the way to manufacturing. So we're not a manufacturer, but we have a bunch of sources we work with, including companies in Maryland. And what we'll do is we'll take a look at the different requirements and go through the process of translating them. So basically, the design process, and you've probably seen different charts like this, is pretty straightforward. But at the same time, what we're doing is something very complex. And all steps of this process, whether they're the technical aspects or the legal aspects or the business and marketing aspects, they are pretty complex. So really what we're looking at is all of the things that are necessary to start a project in such a way that the upfront work is going to pay off in the future. You're trying to avoid mistakes where you don't understand the market, you develop a product and the market's not interested. Or you may not have meet the requirements that your customers have or the expectations that they have. So as you can see, we've got the market needs, the requirements, the concept, the ideas, and in this case, obviously the patent, any type of prototyping, any type of regulation comes into the first phase, which is the concept phase. You're doing system engineering, you're developing user interface, you're developing mock-ups and prototypes, just to verify that the technology works. And then you get into the industrial design. And then the next steps are going to be the design phase. It's concept, the detailed design phase. You're going to prototype. You're going to validate. It may be anything from simple testing all the way through some extensive qualification testing. And as you can see, I've got an arrow that goes back because there's a good chance that you're going to have an iteration of the process. It's as much as, because we're doing something very complex, it's difficult to get the perfect design. And by the way, the prototype, at the prototype phase, the customer will take that and evaluate with their customers, the end users, to make sure it works. And there's always some feedback, some refinements that you go through. Ultimately, it gets produced, and then goes to the end customer, and hopefully you'll be very profitable. So that's the basic design process. That's what we go through. So basically, what we're looking at here is there is a solid-state power emulator, and what we would do, and we would recommend our customer to do, as well as their internal engineering organization, if that they have one, is to really look at the patent first as a theoretical operation. Does it actually work? Request as much information as possible, and that's where DevTech is going to be great, because they'll provide a interface or a connector between the organization and the inventors, and look at any data available, review the simulation, look at the data that's available, request any prototype and test it to verify that it does work. The next thing is, and this is where the most important part is really defining what the goals for this product is, right? So what are the functional requirements? What are the expected deliverables? And then go through the next steps. So when we've designed this, maybe in this case, there may be a specific circuitry you're looking at. So maybe there's a specific operation you're looking for. And then in terms of deliverables, the idea ultimately is taking the technology to manufacturing. And therefore, you'll be looking at some prototyping to verify the design, or you may be looking at some final production items, including a full technical data package. In the case of the prototyping, and in this specific example, again, it's pretty straightforward. We're looking at probably developing a breadboard that would emulate the circuitry that is being patented into the actual circuitry that the customer is designing. So when the Army developed this specific invention, they had a very specific idea in mind. I think it was an IGBT test, low voltage test of a high voltage circuit. Well, the customer will want to adjust that circuit based on their specific operational functional requirement. So the second image on the right is a breadboard. It's an old term used from back in the 60s, I think, where you're basically putting components together. They're cobbled together well enough that they're going to work for your application. But you may also want to go to a final circuit design, and that's what the printed circuit board below is showing. In that case, it's not for that specific project, it's for a different project, but it gives you an idea of that finished product. And the difference between the two is obviously pretty different in time, in terms of a breadboard is a lot cheaper. You don't have the NREs involved with making a circuit board. You don't have the NREs of maybe making an enclosure or any special programming of the circuitry, where you could potentially use an existing board like a BeagleBone, Raspberry Pi, Arduino, or something like that to again verify your process, the IP, and also taking it into an actual product. And then after that, you go through the testing and verifying that your design meets the requirements. And again, depending on what the customer's final expectations, there may be an industrialization for mass production. And so that's the difference between the two images that you see. So that's kind of a high-level explanation of what this would be. And I can, if you want to, I can talk about the couple of other examples of dev tech if you're interested.
Yes, I think that helps people get some perspective and also just some ideas of different kinds of technology. And thank you for taking the time to think through the process for these two other examples. So yeah, we can go to your next slide.
That'd be great. So we have a customer of ours who worked with ECBC, that's Aberdeen Proving Grounds chemical group, and biological group. And what they had was a product called the Biskit. It's a sample for sampling the surface of large surfaces to identify the presence of certain bacteria. And what the Army was interested in is they had come up with this process, and it was just some simple 3D printed prototypes. They had been tested. They looked pretty, they looked like a good product potentially. There was a patent that had been applied for. The problem is it needed to be industrialized because first off, most 3D printed parts, certainly at the time, were not usable in a medical biological type application. There was some sealing issues with this as well. And at the same time, the Army recognized this was something that was needed. So a local company, one of our customers called Quicksilver, actually licensed the product. I believe they pay, I think $1 or something like that for each device that they sell. But what they did is they took the basic prototype and they went through a more detailed design, had the parts injection molded. There's a die cut piece and it's all assembled. And that process was taking a concept, finalizing the detailed design, selecting the right materials, paying for tooling, and ultimately now they're actually selling them on their website as a standard kit that you can buy. And it's a win-win situation in this case because both the Army's making some funds out of it. I believe the inventor had also some funds coming out of it, and the Quicksilver added a product. At the time when they initially brought it in, they were primarily a distributor, so it was a nice add-on. A very different project called the Cool Hand Luke, and I'm not sure where it stands today, and that one I'm showing as an example. It's a interesting idea that the Army came up with where during training, soldiers get overheated. And the idea was, how could we cool them down quickly and potentially use it for other applications? So what you're seeing on the right is a 3D model concept that was prototyped, not exactly like that. It was, I believe the prototype is slightly different to this. And you put your hands inside those holes. By the blood flowing through the veins and going through the rest of your body, they found that it cooled the body temperature very quickly. So it was a very neat application. Some of the ideas the Army had were, in addition to the use for training for the military, they could also use it for sports applications. Maybe it could be used at a soccer camp or at a football game. So for that one, I don't know where the project stands. We had talked with the Army about it because they were looking for some engineering help. And the first thing is, I would believe that if I was the customer, what I would do is I would go through the testing to find out, what the criteria, the properties are. There is a need to redesign to be to re-engineered so it can be carried, more hand or carrying friendly. There may also be some specific design changes depending on what the goals are. So for example, you can see the tarp on top. The tarp could have a tent kind of cover to go around the individual, so there's some shading. There was some interest in possibly using it for marketing. So you could imagine that you would have larger surfaces, so you could have Under Armour, Redskins or Ravens or whatever applications. So again, the idea here is there is a patent. In other words, no one can copy this specific design. It's a utility patent, which means that they can't just do some slight variation, put less holes in it or more or something, or just put some wheels on it. That does not suffice for it. there's a potential application where this could be sold to marketeers, to football fields, to sports organizations. There is obviously some cost that would have to be identified in terms of what the product is going to cost, and that's another thing that's going to happen during the design process, which is, here's the way we could build this. This is the non-recurring cost you may have. Maybe there's injection molding, stamping, custom extrusions, depending again on what you're looking for. So that's kind of the idea behind this, is that ultimately you are able to take the basic concept and take it all the way to production. And even though this looks very simple, there's still some complexity involved, and there's still some requirements that need to be defined. One more example is a requirement is safety. If it's going to be something that you can collapse, you don't want finger pinching. So yes. I think that gives you an idea. Does that make sense?
It does. Thank you. So because I'm flying blind, my screen is frozen. That's the only screen that's frozen. I believe that Barry Datloff is on with us today. This is available for license from the Army Medical Research and Development Command. If you are interested in this technology or the other technology that we talked about, the switch, go ahead and message us in the chat. Let us know. You can contact DefTech directly. We'll have our contact information up at the end of the show today. So if you're interested in either of those, the Cool Hand Luke is available. So thank you very much for that, Cyrus. I think looking at different technologies helps people get an understanding of what they need to consider from a manufacturing perspective. And I appreciate you pointing out that just because something has been patented, that you're looking at licensing a patent, doesn't necessarily mean that it works as you would expect. So some caution there. DefTech supports companies through the entire commercialization pipeline, from searching for the right intellectual property solution to connecting them to resources that they need, to connection with the labs, and ultimately the final technology transfer agreement, which would be a patent license agreement or a cooperative research and development agreement. As we pointed out, learning as much as possible prior to licensing is key to reducing your risk, your business risk. We help companies connect with the tech transfer professionals who will bring the inventor into the conversation so the company can have their technical questions answered. Once a company makes that decision, they've done their due diligence and they decide that licensing a particular piece of technology makes sense for them, and the lab agrees, the next step in preparing to license is developing a commercialization plan. So while commercialization plans are requirements for licensing, and there is a fairly standard template that the DoD uses for their expectations, they also serve as a working document for the company. Once you've made that decision to license, it can be challenging to figure out, how do you propose fees in your plan, and then how do you negotiate for that license? So we are going to talk about that on June 16th, same time, same location, different link, but the same location. So let's return just for a moment to the topic of what DefTech is and why the Maryland Department of Commerce set this program up. Our purpose is to help businesses make use of the extraordinary lab resources that are available in the state of Maryland, particularly the DoD labs. But Maryland we're home to 78 federal labs. That's more than any other state. And most of those state-of-the-art facilities, the highly sought-after expertise, the cutting-edge intellectual property that's available, it's available to help businesses grow. They're not getting patents just for the heck of it. They're getting patents, and business gets to license those patents and use them. I want to thank everyone for joining us this morning. If there are specific topics that you'd like to see us cover, you can add them to the chat now, or you can email us. You can email info@deftechmd.com, and we will see you back here hopefully in 2 weeks. In the meantime, let's all look out for each other. Respect each other. Let's stay home and stay safe. Wear your masks when you're out and wash your hands. Thank you.